Okay, today we're looking at functions and graphs, and we're trying to come up with domain and range. Now, remember, domain is our values for x, and our range talks about our values for y. So a lot of looking at these graphs to start is just kind of evaluating horizontally. I don't know if I spelled that right. Let's just go with horizon there. Horizontally for our domain or our x values, and then we're going to look vertically for our y values. So let's just start with the x. Let's start with the domain and analyze the graph here. The key piece of this is the fact that you have an arrow on the left and right side of your graph here, which tells me that this is going to infinity and negative infinity. So for our domain, we could again say all real numbers. I'll just say all real there. Range-wise, a little bit different. And so we're looking at y is greater than or equal to 0. If you see or unsure whether it's greater than 0 or y is greater than or equal to 0, I invite you to put in this case 2, because we see our x value here is 2. Put 2 into a table and solve and see if you can get 0. If you can get 0, then we're using this. If 2 comes back as an error, then maybe the 2 or the 0 for y is not included. Those are just some side notes. This is a good absolute value graph, and because it's to the right, I could actually come up with this here. That minus 2, actually the 2 will actually be a shift to the left. Let's look at another graph. We're looking at this one here. I like this one. This is off your square root of x parent function, and we're just looking now at domain. A little bit different here because we only have an arrow going in one direction for our x values where we look horizontally, and we recognize, okay, there is a limitation at 4 for x, and because this point here is a filled in circle, they want to include that as an x value. So we're going to say x can be less than or equal to any numbers, basically less than or equal to negative 4. So any numbers less than or equal to negative 4 would be our domain. And then range-wise, we go ahead and we look at that vertical, how we're looking vertically here. And I often look at my y-axis as my reference point, and I see, okay, my y is going to be greater than or equal to 0. That's how we're coming up with domain and range. This question I brought up because we have now just being presented to us this dotted line, and this dotted line actually serves as an asymptote, meaning this is an exclusion. So it's telling us that x cannot equal negative 6, and it's also telling us that x can't equal anything to the left of this asymptote. So without the asymptote, maybe we would have written x is greater than or equal to negative 6, but with it, we have to list our domain as x is greater than negative 6. Notice there's no equal to because we're excluding that with the asymptote. Range-wise, yes, we don't see the arrow down here, but it's safe to assume that our range is probably going to be all real numbers there. All real, because it looks as if it's going in both directions. This was a good one. I actually kind of listed a few examples here. The y is equal to absolute value of x is this line here, and our range, domain and range for that would be, domain would be all real, and range would be y is greater than or equal to 0. If I see this same parent function has shifted down 4, and I kind of added this as a review for translating Parent functions, it's going down to, I think this is 3 here. This is basically y is equal to the absolute value x minus 3. Any number outside your absolute value will create a shift up or down. And domain being, again, all real, and range in this case, y is greater than or equal to -3. And then a little review on the red here. It is y, you could write as y equals x minus h plus k. That's kind of your transformation slash translation equation. So if I'm going left 6, I'm actually going minus a minus 6. So actually I would rewrite this as x plus 6. And then domain the same, all real, range again going back to greater than or equal to 0. This question, if you're presented with, actually is one that's provided you without a graph. And this goes back to that x minus h. And if I have an x plus h, I really had x minus a minus 6. That's why our x value here is -6. And domain being x is greater than or equal to -6. Range being y is greater than or equal to 0. And this last one I pulled up is a good one for a couple reasons. One, just kind of showing you how it looks on Desmos. And there is a bit of it's tricky, this one. So it kind of looks like Desmos is providing us with an asymptote here. And it's hard to uncover that. So what I did is I used the table tool on my Desmos. You'll see the settings symbol in your Desmos, and then you kind of click this table symbol and it'll switch it to a table. And what I did was I plugged in the value -3 and saw that it was undefined, and then I plugged in the value -2.9 and saw that it gave me an actual value. So I kind of, guessed that I have an asymptote here where x cannot equal -3. So with that, I can kind of draw up a domain where x needs to be greater than -3. And then as far as like values for y or your range, this is all real. It's going in all directions. You would get an out as long as you put in a value above -3. You're gonna get a result or some sort of output.